DD is producing a 32 MB random file instead of 1 GB. I wanted to produce a 1 GB random file, so I used following command. But instead, every time I launch this command I get a 32 MB file. What is wrong? Edit. Thanks to great answers in this topic, I came with solution that reads 32 chunks 32 MB large, which makes 1 GB. Other solution was given that reads 1 GB straight to the memory and then writes to disk. This solution takes a lot of memory, so it is not preferred.
DD may read less than IBS. Note, BS specifies both IBS and OBS, unless iflog equals full block is specified. 0 plus 1 records in indicates that 0 full blocks and 1 partial block was read. However, any full or partial block increases the counter. I don't know the exact mechanism that makes DD read a block that is less than 1 G in this particular case. I guess any block is read to the memory before it's written, so memory management may interfere, but this is only a guess. Edit. This concurrent answer explains the mechanism that makes DD read a block that is less than 1 G in this particular case. Anyway, I don't recommend such large BS. I would use BS equals 1 M count equals 1024. The most important thing is, without iflog equals full block, any read attempt may read less than IBS, unless IBS equals 1. I think this is quite inefficient though. So if you need to read some exact amount of data, use iflog equals full block. Note, iflog is not required by POSIX, your DD may or may not support it. According to this answer, IBS equals 1 is probably the only POSIX way to read an exact number of bytes. Of course, if you change IBS, then you will need to recalculate the count. In your case, lowering IBS to 32 M or less will probably fix the issue, even without iflog equals full block. In my Kubuntu, I would fix your command like this.
BS, the buffer size, means the size of a single read, called down by DD. For example, both BS equals 1 M count equals 1 and BS equals 1K count equals 1K will result in a 1 MB file, but the first version will do it in a single step, while the second will do it in 1024 small chunks. Regular files can be read at nearly any buffer size, as long as that buffer fits in RAM, but devices and virtual files often work very close to the individual cores and have some arbitrary restriction of how much data they'll produce per read core. For /dev/urandom, this limit is defined in urandom_read in driver/char/random.c. This means that every time the function is called, it will clamp the requested size to 33554431 bytes. By default, unlike most other tools, DD will not retry after receiving less data than requested. You get the 32 MB and that's it. To make it retry automatically, as in Camel's answer, you need to specify iflog equals full block. Note also that the size of a single read means that the whole buffer must fit in memory at once, so massive block sizes also correspond to massive memory usage by DD. And it's all pointless because you usually won't gain any performance when going above 16, 32 MB blocks, 6 cores, and the slow part here, the random number generator is. So for simplicity, just use head, C1G/dev/urandom is greater than output.
If you want to support the channel, please consider liking and subscribing.